how to use the DoE method to make a concrete mix design. Now there are 5 steps to DoE method. The first step is to calculate the water-cement ratio. Now we look at the tables to calculate the water-cement ratio.
First of all, we're going to look at the type of cement that we have. We have ordinary Portland cement. Next, we're going to look at the type of coarse aggregate that we are going to use, which is uncrushed. We're going to look at the strength at 28 days, which is 40 Newton per millimeter cube. And we have to notice that this strength is for the water-cement ratio of 0.5. Next, we're going to look at the graph. First of all, we have to find the water-cement ratio 0.5 and then the strength 40 on the graph. We have to see where do these lines meet. After marking the line on the graph, now we have to look at the given strength for our concrete mix, which is 30. Now we're going to draw a line from 30 until it meets the curve. Okay, after marking it on the curve, we're going to see where does the line meet on the x-axis, which is 0.6.
Now we'll look at the second step, which is to calculate the water content of the mixture. Okay, for the water content, we're going to look at this table. Alright, so from our question, we can see that the maximum size of our aggregate is 10 mm, and it's uncrushed. And we'll see the slump size in slump height of our mix, which is 15 mm, which falls into this group. So the water content for our mix will be 180. Okay. Will you look at the third step, which is calculating the cement content. Now, to calculate the cement content, we can use the water content and the water-cement ratio that we have already found. Okay, so the water-cement ratio that we have found is 0.6, and our water content is 180 kg per meter cube. Okay, now the formula for water-cement ratio is okay. Now if we just rearrange this formula, we can find that cement content equals to water content divided by the water-cement ratio. So we can just put in the values to find the cement content. Okay, now the fourth step in DoE method is to calculate the total volume and the content of the total aggregate. Okay, the equation for calculating the total volume is this one. Okay, this symbol resembles the density of the cement, and this one is for water. Now we put the values in and we get 0.748 as the total volume ratio. Okay, now we calculate the total aggregate content. So we have to multiply the ratio that we have found with the density of the total aggregate, which is 2600. And from there we find the total aggregate content. But we have to calculate the total content for the fine aggregate and the coarse aggregate separately. To find the content, we have to first look at the graphs in the last table. Okay. Now, first of all, we have to find the slump. Our slump height is 15, so it falls in this range. Okay. Now we look at our water and cement content here, which is 0.6, and we draw a line up to zone 3 because our grade is 3. And now we see where the line meets on the y-axis. So this can be considered as 35. Okay. From there we use 35 over 100 and we multiply it with the total aggregate content. And we get 659 kg per meter cube. And for the coarse aggregate, we use the whatever is left from the 100%, which is 65. And we multiply it with the total aggregate content, and we get 1224.921 kg per meter cube. Okay, that's all the 5 steps for the DoE method.